Welcome back. We're going to go over steps for solving story problems, and then I'll do a couple examples for you. Here we go. Step 1. Draw a picture. There's probably nothing more important than starting with a picture, because if you are not visualizing or understanding the problem, you will not apply the correct physics to it. And again, this is not a math class. The biggest challenge in physics is problem solving. And so in order to solve a problem, you have to understand the question. When you draw a picture, it should be a semi-detailed picture. You don't have to be a magic artist, but you should include things like the origin, enough information for you to understand it. So an example. I need to set a reference point. I'm going to say that down is positive. That's really important because it makes my acceleration positive, because my acceleration is going in line with my reference point. If I put my reference point going up, then my acceleration would be going down still because of gravity. It would be opposite of my reference point. So that means my A is going to be positive. Number 2, alphabet soup every time. Okay. Now when I set my work up, when you see the solutions to my problems, you will almost always see a picture at the top, and then if I have room, I'll list the variables here or right here, and I'll draw a line, and that's my working area, and then all my math and my reasoning will be below that. Okay. We need to collect. Those are the same variables that you're going to collect every time you do a problem, and fill them in as best you can. So if I'm going to drop a ball off a 30-meter cliff, the change in displacement is going to be 30 meters. Now, is it going to be positive 30 or negative 30? Well, if I set my origin here where x naught is 0 and my final position here where x is 30, then my change in position in line with my reference point is going to be positive. That's important. My final velocity is going to be down here at the ground, the impact velocity. I don't know what that is. That might be what I'm asked to find. The initial velocity is implied. If I am dropping a ball, what velocity is it in my hand before I drop it? 0. So my initial velocity in the y dimension is going to be 0. Now, because we're in the y dimension, it's just an up-down problem. There's no left or right. My initial velocity in the y is 0. My acceleration in the y, due to Earth's gravity, is 9.8 meters per second squared. And you got to figure out, is that positive or negative? Well, you look at your reference point. So because the force of gravity is accelerating the ball downwards at 9.8 meters per second in line with my reference point, it's going to be positive. The time is not given. I'm just going to leave it blank for now. It's possible that I just don't care about time, so don't freak out. Okay? I might be asked to find time. I could be asked to find time if I had this distance, this acceleration, this starting velocity. You could kind of start to think about those kinematic equations. If I was going to change my velocity at 9.8 meters per second for every second that it falls, starting from 0 meters per second, and I knew I started at 30 meters, you might imagine that these ms and m's could cancel out. I might end up with time. I could solve for time in here, right? So we're going to keep this simple. We're going to stick with the velocity. I'm looking for velocity. So picture alphabet soup. Number 3, I have to choose my equation. When you choose your equation, look at what you have, and that's why these variables should be listed the exact same way every time. What you'll do is you'll train your brain to see patterns. It will be to your benefit listing this stuff out. Already I have more work done than half of you do on most of your problems. That's not a good thing. write this stuff down so you have something to go back and look at, so you can study from, so you can understand the problem well. This doesn't take long to do, and the more you do it, the quicker you'll get at it. So, choose my equation. In this case, I'm going to choose, this was the only formula of my kinematic equations that did not have time in it. And so I could probably go around the horn and solve for time and then pick another equation and use that time in that equation, but then I'd be doing 2 steps instead of just going to the one immediate step. Number 4, remove zero terms, solve symbolically. So solving symbolically means that I want to get this v by itself. That's fairly simple at this point, it's just squared. I just got to get rid of that squared. Remove my zero terms. Because I'm starting at v naught of 0 meters per second, this whole thing goes away. And I can rewrite this symbolically to show that the velocity, the final velocity, is equal to the square root of 2 acceleration times the displacement. Number 5, plug in numbers, be careful of conversions. Okay, so 9.8 meters per second squared and 30 meters. Okay, so when I do that math, I get 24.3 meters per second, which is my final velocity. Check my units, meters per second is a velocity. That all makes sense. So this is what I expect when I say show your work, show your complete work. You should have a picture with reference point. You should have a list of variables with units. You should have the correct equation. You should solve symbolically, plug your numbers in, and then circle your answer. If you do not have all these pieces to your work, then you have not done your part as a student, as somebody trying to learn this, right? When you make $100,000 as an engineer and you can do all this in your head, then you probably still need to show your work, because your boss is going to want to know how you came to that answer, because he probably doesn't know how to do the math. And so you're going to have to show him how you came to your answer. So it's not going to go away. Okay? Let's go ahead and do an example. Bob drops a quarter off a 375 meter tall building. How fast will it be moving when it hits the ground? Alright, so let's draw a picture. Ball is falling, reference point. Okay, done. Okay, add some numbers. The height here is 375. Okay, collect my variables. Choose my equation. Solve symbolically. And get rid of my zero terms. Plug in my numbers. Plug it into my calculator. Alright, so I know I've been doing these a lot, and I'm going from my notes, but it took me about 20 seconds maybe to draw a picture, collect my variables, choose my equation. Now you may have spent a little bit more time choosing your equation and hemming and hawing about what to do and how to set this up, and that's fine. Okay, add a minute. Okay, and then once you have this part, get into symbolically solve and then plug in your numbers. Shouldn't take you too much longer. It might take you a little bit to plug this into your calculator, but this question here is a 2-minute question. Okay, when you're thinking about these big tests like the ACT or an AP Calc test or AP Physics test, you know, you don't have 25 minutes to try and do this. So you can handle this work in these pieces in that order in a very short amount of time. Okay, so all right, let's try one more. Now for this one, I'm going to read the scenario to you. I'll put it up here on the board. I would like you to pause the video and try to put that into practice. So draw a picture, collect your variables, choose your equation, solve symbolically, plug in your numbers, and see if you can get that crunched out in your calculator. Okay, so I'll give you a second, go ahead and pause it. Okay, Susie slams on her brakes as she's coming down a canyon road. Small family of raccoons are crossing the road in front of her. Oh my gosh, 11 meters away. After 2.5 seconds, her car barely comes to a stop. Oh my goodness, thank you. How fast was she going? Okay, so let's start with a picture. That's a raccoon. You could label it if you want to. My reference point this time is going to be positive to the right. So this little symbol here means positive. Positive is to the right, meaning backwards is negative. My initial velocity, that's the question. And I know at the end here she came to a stop. So collecting variables. This time my final velocity is 0. My initial velocity is the question. Acceleration is 9.8 meters per second squared. If it was in the y dimension, right? It's not in the y dimension. You got to be careful. Remember that that bullet I had down here about making sure your variables agree with each other? Okay. This velocity is in the x dimension. Okay, we're talking about a car going back and forth, not up and down. And so therefore my acceleration cannot be 9.8 meters per second squared. Thought I'd catch you on that one, so be careful. And then the time, 2.5 seconds. Okay. Now when I'm looking at my kinematic equations, I don't really know my my initial velocity. I don't know what my acceleration is. So we've got displacement, final velocity, and time. So I'm going to go with the formula that does not have acceleration in it, because I don't have it. I'm missing it. So I'm going to see if I can solve this without my acceleration. And so that would be the delta x equals 1/2 v naught plus v times t. Solve symbolically for my v naught, so I'm looking to get this guy by itself, and so I can take both of these over to the other side, so that becomes I'm going to divide. If I divide a half, that means really I'm going to be able to multiply, so I'll do it longhand here. So if I divide by half and divide that t over, that's going to be equal to v naught plus t, right? And then oh, I got to get rid of that 0 term, so that goes away, right? Alright, so I'm left with, and I'm going to change that, so it's going to be a 2 on top, so 2 delta x over t equals v naught. And I think we're good. Okay, so, and that's okay if it takes you that long and you do things out of order. Okay, I forgot about the v goes to 0, okay, because we got rid of our 0 terms. Otherwise, I could have subtracted it over here. When it came time to plug in numbers, it would have been obvious that, oh, minus 0. That'd be okay. Okay. All right, so now we're going to plug in numbers. So I've got 2 times 11 divided by 2.5 seconds. And so my initial velocity would have been 8.8 meters per second. All right. Now, I know I'm harping on this. These are pretty easy problems. You will come across difficult problems where you have to use a 2-step process where you're going to use 2 different equations, and you're going to have to do some substitutions, and you're going to have angles and cosines and sines, and it's going to get more complicated. It's critical that you draw a picture, collect variables, choose your equation, solve symbolically, plug in your numbers, circle your answer with the correct units. Okay? It's critical that you follow this pattern so that when you come up against a problem you don't know how to do, because I'm not expecting you, this isn't solving answers, it's solving problems. It's things you don't know how to do. And so doing this process, you'll be able to do things that you don't know how to do by just keeping your head down and following the procedure. Okay? So practice the procedures now when they're easy and they seem silly, so that when you get to the harder things, and they will get much harder, This is one-dimensional motion, pretty straightforward. Two-dimensional motion becomes twice as hard. So be ready for that, and when you get to class, we will do some more practice problems with this. All right, thank you.